Good morning, good afternoon, good evening, whenso you're watching this television, this video, anywhere, anytime. Uh, Regards from my side, we are going to start with the second part of the electrostatic chapter. In the previous class, I've already explained the meaning of electrostatics and actually what is happening. Let me just give you a recap. Electrostatics means the study of charges at rest, and the charges are transferred from one body to another in the form of electrons. Electrons, when they go from if they're lost from a body, it attains a positive charge, and if any body is gaining electrons, it gets negatively charged. Charging can happen in three ways. I have discussed this thing before also. One is by simple friction, second by induction, third by conduction. Now let's come to the properties of charge in this class. Properties of charge. Properties of electric charge. Very first thing, electric charge is quantized. Electric charge is quantized. Quantized. As you know, quantize means, quanta means a packet. So all the charges which are transferred from one object to another, they are an integral multiple of electron. इसका मतलब Q is equal to NE, where N is any integer. इसका मतलब क्या है? जैसे आपको पार्ले जी के बिस्किट पैक खरीदने आते हैं, क्या तो एक बिस्किट दे देगा, एक नहीं देगा, वो क्या देगा, आपको पैकेट देगा. सिमिलरली अगर आप चार्ज ट्रांसफर करने की बात कर रहे हैं तो कोई 1, 2, 3 कूलम का चार्ज ट्रांसफर नहीं होगा. जो भी चार्ज ट्रांसफर होगा 1.6 इंटू 10⁻⁹ के टर्म्स में होगा. 10 टाइम्स, 20 टाइम्स, 30 टाइम्स 1.6 इंटू 10⁻⁹. इसका मतलब है चार्ज एक जगह से दूसरी जगह आएगा, एक पैकेट में आएगा. उस पैकेट की मिनिमम वैल्यू क्या है? E. What is this E? This is the electronic charge, 1.6 10⁻⁹. So if I say plastic is gaining certain charge will be an integral multiple of minus 1.6 into 10⁻⁹. On the other hand, if I say here are losing charge, I'll say a number of electrons are going out from it. That's why again it is an integral multiple of 1.6 into 10⁻⁹. The object which is losing electrons is gaining a positive charge. The object which is getting negatively charged, it is actually gaining electrons. It is just this way. Second point, charge is neither created nor destroyed. Is neither created nor destroyed. That means it is law of conservation of charge. Law of conservation of charge. Conservation of charge. I want to tell you this thing. This is applicable to all chemical and nuclear reactions. It is just like a universal law. Law of conservation of energy. It is valid in all cases. Similarly, this is law of conservation of charge. It is valid both in chemical and nuclear reaction. But you say, what about the annihilation reaction? Yes, or what about the pair production reaction? There also, what is happening? Mass is, if I have an electron and I have a positron, both of them, they are combining together and it is forming energy. So, what is happening? An electron and a positron pair, they are combining with each other and is forming energy. In this case, what is the charge on the left hand side? 0. What is the charge on the right hand side? It is 0. If I do the opposite, the pair production, just the opposite of it, that means when energy is there and a pair production is there. Production means an electron and a positron is produced. Here also charge is conserved. So it is law of conservation of charge. Is it clear? Okay. Now let's come to the third law. Third law says about the additive nature of charge. Additive nature. Additive nature of charge. What do you mean by additive nature of charge? That means if an object is there, let me consider randomly an object. The charge on it is 1 coulomb. Q1 is 1 coulomb. Then another charge is there plus 2 coulomb. Then Q3 charge is minus 5 coulomb. Now what is the total charge on it? Algebraically, we are going to just add these charges. So it becomes plus 1, plus 2, it becomes plus 3, plus 3 and minus 5. So what is the total charge on it? The total charge on it is minus 2 coulombs. That means the total charge on an object is simply the algebraic sum of all the charges on that object. Additive nature, this is what additive nature is. Okay, is it clear? Okay. Now I come to the fourth point. Fourth point is clear to everyone. Like charges repel, like charges repel, and unlike charges attract. Unlike charges, this is a basic law. Everyone must be knowing this. Even a layman who knows this, that like charges repel and unlike charges attract. Plus plus repel or attract? Yes, plus and plus will repel. Minus minus again repel. Plus minus attract. Minus plus attract. So all like charges will repel each other, unlike charges will attract. Let's quickly summarize. What have we done? We have learned the properties of charges. The very first thing is electric charge is quantized, that is Q is equal to plus minus Ne. Second is the law of conservation of charge, that is charge is neither created nor destroyed in any nuclear or chemical reaction. The third one is the additive nature of the charge. The total charge on an object is actually the sum of all the charges which are present on it. And we come to the fourth one, that like charges repel each other and unlike charges attract. Okay. Now based on all the theory which we have learned in this class and previous class, let's do few numericals. Let's start from the very beginning. How many electrons are there in 1 coulomb of charge? Minus 1 coulomb of charge. Let's take it. How many electrons are in minus 1 coulomb of charge? Let's see. What is the total charge over here? Answer here is Q is equal to minus 1C, but I know E is equal to minus 1.6 into 10 raised to minus 19 coulombs, and just now we've done quantization of charge, so Q is equal to Ne. I want the value of N over here. N is Q by E, so it becomes minus 1C divided by minus 1.6 10 raised to minus 19 coulombs, so it becomes, it goes up 1 by 1.6 into 10 raised to power plus 19, it becomes 100 by 160, or I'll just say 100 by plus 160 into 10 raised to power, or let's take it minus 100 by plus 19, so I'll just make it as 1000 by 160 or 1600 by 16, 10 raised to power 18, so it becomes 6.25 10 raised to power 18. These many electrons, it will not be having any units. These many, this is the number. The same unit has been cancelled. So these many electrons are present in how many coulombs of charge? 1 coulomb of charge. The question can change 10 coulombs, you will accordingly change the value of Q and so. Is this clear? Okay. Now let's come to a more practical numerical, let's say. Question is, a plastic comb is rubbed on here and is found to carry onto the charged by minus 3 into 10 raised to minus 6 coulombs. Find the gain in mass of comb. It looks quite a bit weird. We talk about charges and then we talk about the mass. How is it related to each other? Because I'm talking about a plastic comb being rubbed on here and getting negatively charged, but I'm asking what? Gain in mass of comb. Let's see what is asking. Here, what is the charge on the cone? The charge on the cone is minus 3 into 10 raised to minus 6 coulombs. According to our quantization relation, Q is equal to Ne. That means this has got negatively charged because it must have gained electrons from here. So how many electrons have been gained? Electrons, number of electrons gained by cone is equal to N, which is equal to Q by E, which is equal to 3 into 10 raised to minus 6 coulombs, and here E is equal to what? Minus 1.6, 10 raised to minus 19 coulombs. So this is minus 1.6, 10 raised to minus 19 coulombs, as we have done before also. 3 by 1.6, 10 raised to power, this goes up, it becomes minus 13. This 0 I can remove from here, and this decimal I can remove and get a 0 for here. It becomes 1, 16 ones are 16th, and how much is left? 14 is left. So 16, it comes out to approximately no, 7 or something. 10 raised to power minus 13. This is the number. This number. Now I am talking about the mass gain. Mass of one electron. Mass of one electron is equal to 9.1 10 raised to minus 31 kg. So mass gained by what? Mass gained by our cone is equal to this much mass, N into this mass of an electron, which is equal to 30 by 16, 10 raised to minus 31 into 13 into 9.1 into 10 raised to minus 31 kg. What's the answer? This is all it is. I quickly repeat. Here the question was, a plastic cone is rubbed on here and is found to be charged by this much charge. Find the gain in the mass of the cone. Here the total charge gained is minus 3 into 10 raised to minus 6 coulombs. Q is equal to Ne according to the quantization relation. E is equal to minus 1.6, 10 raised to minus 19 coulombs. So number of electrons gained by cone becomes N is equal to Q by E. The value of N we are finding it out. Then we are multiplying it with mass of one electron. Is it fine? Okay. Now let's wind up till here only, and we'll meet again in the next class. Fine. Okay. Goodbye.